Welcome to day 14 of our school year. Go ahead, fill that in. Our beginning fraction, well, our denominator is always 180 because that's the total amount of school days. Anytime we're having a denominator, it's going to usually be the total amount of something. And we are in day 14. So that's our numerator. I'm going to find the factors of our numerator. Two factors we always know are 1 and the number itself. Using the commutative property of multiplication, I can do 14 times 1. Now I'm going to go through my possible factors in an orderly fashion. So I tried 1, now I'm going to try 2. So the divisibility rule for 2 is that it ends in an even number. 4 is an even number, so 2 is a factor. 2 times 7, 7 times 2. The only numbers I need to try now are between 2 and 7. The whole or counting, the natural or counting numbers between 2 and 7. After 2, we try 3. The rule for 3 is that we add the digits together. 1 plus 4 equals 5. 5 is not a multiple of 3, so 3 is not a factor. We try 4. 4, 8, 12, 16. 14 is not in that list of multiples, so 4 is not a factor. We try 5. The rule for 5 is that it ends in a 0 or 5. It ends in a 4, so 5 is not a factor. We try 6. The rule for 6 is that both 2 and 3 are factors. 2 is, 3 is not. So 6 is not a factor. Then we get to 7, and we are done. So let's go ahead and list our factors from least to greatest. 1, 2, 7, 14. This has more than 2 factors, so that makes it composite. And now we need to find our greatest common factor. So let's start with 14, because that is our greatest factor for 14. Let's see if it's a common factor for 180. It does not matter what your groups of 14 look like, as long as you have 14 in each group and you do not have shaded with unshaded. Okay. I'm using my decomposition here to be able to do it, because 8 plus 6 is 14. 4 plus 10 is 14. 10 plus 4 is 14. 6 plus 8 is 14. 10 plus 2 is 14. 8 plus 6 is 14. 4 plus 10 is 14. 10 plus 4 is 14. 6 plus 8 is 14. I have 12 left over, so 14 is not a factor because I have a remainder. And you cannot have remainders if it is a factor. We'll divide it perfectly. So 14 didn't work. Let's try groups of 7. So remember to keep your shaded and your unshaded separate. Okay, 5 plus 2 is 7. 7, 1 plus 6. 4 plus 3. And then 7. You have a different strategy to make your groups of 7. Go ahead and do it, but we need to just make sure each one has 7. And they have to be equal groups, otherwise we're not dividing them the way we should. And it looks like I have 4 left over. Let's see, it looks, I have 4 left over, so that means that 7 did not work. Okay, let's try 2. Okay, remember to keep your shaded separated from your unshaded. Two worked. There are no remainders. So now I'm going to find how many total groups of 2 I have. Each of these rows has 5 groups of 2, so I can count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. We have 5, 6, 7 of those groups of 2 shaded in. Okay, so now we're going to do this simplifying with our algorithm. Now that we've done our dividing with our model, we're going to do the same thing but just with numbers. Okay, so we're going to divide our numerator and our denominator by our greatest common factor of 2, because we divided the shaded area into groups of 2 and the whole thing into groups of 2. Let's see, I know 2 times 50 is 100. Numbers the same, zeros a game, more on top, no need to stop. Let's see, 2 times 20 is 40, because the placeholder moves it over a place, and then 2 times 2 is 4. Numbers the same, zeros a game, more on top, no need to stop. And 2 times 20 is 40. Numbers the same, zeros a game, we have no remainder. Add up these partial quotients. 0 plus 0 plus 0, 5, 6, 7, 8, 9. Okay, now over here, I know that 5 times 2 is 10. More on top, no need to stop. Numbers the same, zeros a game. And 2 times 2 is 4. Numbers the same, zeros a game. Add up our partial quotients. 5 plus 2 is 7. Now you did not have to do it my way to get to the same answer. You may have already recognized that 40 would work here. You may have already known that 2 times 7 is 14. I just want to show you that there's more than one way to get to the right answer, so use the multiples you know to get to that answer. Now we're going to check divisor times quotient plus remainder. We don't need to add the remainder on either one of these because it's 0, and the identity property of addition says when you add 0 it stays the same. 2 times 7, okay. 2 times 0 is 0, 2 times 9 is 18, 2 times 7 is 14. Okay, 180, that matches my dividend up here. 14 matches my dividend up here, so they check, check, check. That means for sure my numerator is 7 and my denominator is 90. Now that we've done it in 2 ways, let's go ahead and write it down in our data collection page. Okay, trimester 1, week 4. Today is 8/27/19, and our fraction for today is 7/90. Let's go ahead and get out our number line. We did groups of 2. So the last one I have listed is 1/90. Then we have 1 2 pieces, so we need to get down 2 90ths, which is equivalent to 1/45. 3 90ths, which is equivalent to something in the 3's and all the way down to 1/30. 4 90ths, which is equivalent to 2/45. 5 90ths, which is equivalent to something in the 5's and 1/18. 6 90ths, which is equivalent to something in the 3's, the 4's, the 6's, and 1/15. And 7 90ths. There's nothing below it, but there is just the one above it, 14 180ths. So this is our equivalent fraction in lowest terms, or our simplest form. Okay, let's go ahead and put our number line away, erase the worksheet, and thank you for joining me.